Hello, everybody. Good morning, good afternoon, good evening, based on your time zone. My name is Musab Marka. I'm currently a PhD student at Technion Haifa. Today, I will give a presentation about reducing construction and demolition waste through lean production. So we will talk about introducing the centralized mixing station as a practical tool for lean constructions in order to supply cement, mortar, plaster, and glue to multiple operations in a high-rise residential construction projects. This research is divided into two stages: qualitative analysis and the quantitative analysis. The aim of this study is to evaluate the reduction in construction waste due to implementing the centralized mixing and supply of bulk materials, which based on supplying the material based on a request from the subcontractors to maintain two main lean principles: just-in-time delivery and 5S. First of all, I will give a brief description about lean construction and its principles. So lean construction refers to the application and adaptation of the underlying concepts and the principles of the Toyota production system. Its focus on reducing the waste, increasing the customer value, and continuous improvement. 5S is one of the lean principles, which is a systematic method for organizing the work environment and the workplace. It consists of 5S: sort, set in order, sustain, standardize, and shine. The first step is to sort everything in the work areas and to identify what is required to perform the work. Set in order: in this stage, all the materials and equipment are set in order using planning and labeling. So in this stage, the focus will be on the storage areas. Shine: cleaning the workplace, and this including placing waste bins and make system for evaluation the individual works, like for example, cleaning the workplace daily after the workers finish their work. Standardize: requires the operations in the workplace to be in a standard fashion and according to the standards and codes. And the last S is sustain: to make sure that the standards are committed from workers. Weekly checking is performed to guarantee the standards remain. In lean construction and in lean in general, Techno Ono defines 7 types of waste: waste of transportation, inventory, waiting, motion, overproduction, overprocessing, and defects and rework. The first waste is transportation, which includes any unnecessary movement of materials from its manufacturing until it becomes a finished product, which does not add any value to the customer. Inventory: it represents any material or any product that are sitting without any processing on them. Waiting: waiting also, it represents any subcontractor, any product, any equipment that are sitting in the production line without any processing, since the work prerequisites are not required. Motion: motion represents any unnecessary movement of people or in the site. The difference between motion and transportation: that motion belongs for people and the humans, while transportation related for equipment and materials. Overproduction means that producing more than we need, or in other words, producing the product without being requested from the next step in the production line. Overprocessing means adding a features to the product which is not requested from the customer. So the customer is not willing to pay money for these features. And the last type of waste is defects, which mean producing the product that does not satisfy the client requirements, which in turn needs to be reworked. Research methodology and data collection. We selected for our research a case study. And the reason why we selected the case study, because the case study is a suitable research method for construction management, since each case study has its unique features. We studied two construction companies. Company A, which is a leading company in the area of lean. They started their lean journey before 10 years, and they are motivated to implementing innovations in the construction industry, and each year implemented new lean tools in their construction site. So recently they implemented the centralized mixing as a way of reducing the construction waste. And company B, which is traditional company and works in a conventional way, as we see in figure B, like for example, each subcontractor has its own mixer or has its own container to mix the materials. Also, in our research, we set many interviews with project manager, site engineers, site superintendents, and even the subcontractors themselves in order to see what they are feeling about implementing the mixing station. Now I will give a brief description about the centralized mixing station in Company A. The mixing station consists mainly of three mixers as seen in figure A, each mixer for a specific material. For example, the first mixer is for mortar, the second mixer for gypsum materials, and the third mixer for glue materials. Also, in the mixing station, there is a can-pan tool, which represented by this screen. So each subcontractor in the workplace, he has a button erected on the left. He can push the button and send a signal for the worker in the mixing station, which seen in this screen. Each digit represents something. For example, the first digit represents the work location, which is floor number 1. The second two numbers represents the material code. Each material has its own code. Like the cement has the code 81. The gypsum, for example, has code number 50. And the third number on the screen represents the quantity requested from the subcontractor, which means 6 containers. So the worker in the mixing station now knows to which place he should deliver the material, what is the material requested, and what is the amount requested. So he will prepare the material as seen in figure C, and he will deliver them by a lift erected beside the station. After he finished this mixing, he will clean the mixing in order to keep the mixing station clean and sustained as seen in figure D. Results and discussion. In this section, I will present the results from the qualitative analysis. The first point is eliminating the non-value adding activities, and this satisfied by providing the subcontractors with the ready mixed materials and enabling them to devote their materials to value adding activities. Also, it eliminates the non-value adding activities by removing the necessity to bring workers to clean the construction site and deliver these materials or these waste materials to a specific location in the floor, and after that asking the crane to deliver these waste from the upper floors to ground floor, which in turn you need to bring trucks and deliver these waste by trucks to the landfill and paying money to dumping these waste. B, keeping the construction site clean and in order, which in turn can reduce the accidents results from slips and trips, so it improves the safety issues. 4, improving the mix properties and characteristics. A worker in the mixing station mix the materials for all the construction site and for all the subcontractors will mix according to the ratios and specifications. This will standardize the work, which is a lean goal. 5, improving the mix quality. And this satisfied by avoiding mixing two different materials with different characteristics in the same container, which results in a problem. For example, plaster cracks resulted from mixing mortar in the same containers where you mix gypsum materials. Since the gypsum particles, when it absorbs water, it swells and cause a crack problem in the plaster, and the plaster will be cracked and dislocated. 6, supporting control and monitoring of materials. The presence of material in a specific location helps in identifying and recognizing the consumption of each material daily. Also, it helps in keeping the materials in a safe place from weather conditions. 7, eliminating material waste. This is satisfied by mixing in the exact quantity requested by the subcontractor. Because in the conventional way and in the traditional way, the subcontractors mix the material in a random way. So at the end of the day, the surplus material will be wasted. Like at the end of the day, when the subcontractor finishes the work, sometimes there will be surplus material. So what he will do with this material, he will waste these materials because he doesn't pay money for this material and he cannot use it in the second day. So he will throw it out. But in the implementing the centralized mixing station, we are implementing something we call it in lean pull instead of push. So the materials are pulled from the subcontractor in the exact quantity requested from him, instead of pushing the materials for the subcontractor. As a conclusion, we can say that implementing centralized mixing and supply of bulk material as a lean construction concept demonstrates that lean principles play an important role in reducing different types of waste and energy due to eliminating certain energy consumption operations in the construction industry. It reduced the non-value adding activities by improving the individual subcontractors' operations. It improves the non-value adding activities by removing the necessity of bringing workers to clean the construction sites and deliver all these wastes to the landfills. It improved safety issues by reducing the accidents and the slips and the trips, since the construction site is clean and in order. And the quality of the mixing is improved, since only one worker in the mixing station is mixing for all the subcontractors and he's committed the standards and the codes. So we can say that the centralized mixing station can potentially address environmental waste control through reducing the amount of wasted material and their transportation to the landfills, which can be translated to greenhouse gases and carbon footprint. Future research. This paper shows the first research, which is qualitative analysis and the qualitative assessment of the impact of implementing centralized mixing and supply of bulk materials. A second stage that quantifies numerically the mixing stage and material waste reduction is ongoing. And thanks very much for your listening. And now questions time.